Okay, solving logarithmic and exponential equations. Just basically solving an equation that's got a log in it or an exponent. We alluded to this a little bit before, but this whole take out your notes, open the properties of logarithms. We've kind of gone away with a lot of the properties in logs. We'll do a little bit more of that in pre-calc. Here we go. So I'll go over 4 methods or strategies that you'll want to do to try to solve logs. The first one is if the bases are the same, then their exponents must be the same. And what I mean by that is, let's say I've got 5 to the x power is equal to 5 to the second power. Since the 5's are the same, I can just say, all right, well then x has got to be equal to 2. So I've got 2 to the 4x power, but 32 isn't written as 2 to some power. So I got to figure out, all right, 32, what is that? That's going to be 2 to the, let's see, to the third is 8 times 4, so 2 to the, I believe, 5th. Okay. Now the reason I'm rewriting 32 as 2 to the 5th power is so I have a common base. Okay, rules of exponents. These exponents here are going to get multiplied. So I'm basically solving 4x is equal to 5x minus 1. Don't forget to distribute that 5 to both. So with a little bit of algebra, take the 4x away from both sides, add 5 to both sides, you get x is equal to 5. So that's strategy 1. Make sure or try to get all the bases equal to each other. Okay. Another way you could do this is you could take and look at, sorry, not 14, it's 15. You could try to make these into the same base, but you're going to have a tough time with 15 making that 4 to some power. So what we're going to end up doing is taking the log to both sides. Okay. So since this is base 4, we'll go log base 4 to both sides. They're inverses of each other, so they should cancel each other, and you're left with log base 4 of 15. Now, we're not going to come up with that answer off the top of our head. I don't expect you to guess what 4 to what power is 15. If we could, we would have solved the problem right away. So what you can do is you can make this, what I say, calculator ready. So you can get it so you can actually type into your calculator. So what you do is you take the common log divided by the common log, and you can take the common log of 15, which is the number, over the common log of 4. Now, I would say that is calculator ready. So if on a quiz, test, or anything like that, it says leave it as calculator ready form, go right ahead. But if you want to calculate it out, you can. So make sure you take the log of 15. That's going to be some decimal, 1.176. You got the log of 4, which is going to be some decimal of 0.602. Divide those out. So let's see, 176. Again, the more the decimals you keep, the better your answer is going to be. And it is about 1.95. Okay? So that means 4 to the 1.95 power will give you 15, or roughly 15. So that's method 2. Okay, both of these are working when it's exponential equations that we're solving. Either try to write them as the same base or take the log of both sides. Okay, now when you have the log, method 3 is if I'm seeing log, I'm going to check to see if I have the log of the same base to both sides, which I am. They're both log base 4. And if they're equal, that means that whatever's inside of those parentheses has to be equal as well. So I can just set x plus 3 equal to 8, x plus 17. So with a little bit of algebra again, okay, we're going to take and subtract that and get 14. We're going to subtract x and get 7. So we end up with x is equal to negative 2. Now, I'm going to have to check to see if that answer is going to work because I can't take the log of negative numbers. But if I put it in for x, negative 2 plus 3 is 1. We're good to go. And then 8 times negative 2 plus 17, that's going to give you 1 as well. So x is equal to negative 2. Again, you can't take the logs of negative numbers, but when you put negative 2 back in for x, it works out to be negative values. Yeah, again, those are extraneous solutions. don't remember what that is. Okay. Number 4, method number 4, it's make both sides the exponent of the same base. And what I mean by the same base is I'm going to look at the log, base 4, but there is no log over here on the other side. It's just the number 2. So this is log base 4. I'm going to make 4 the base on both sides, and I'm going to make this the exponent. And the reason why I'm doing that on the left side is that those are inverses. They'll cancel out and I'm left with x plus 3. And whatever I do to one side, I got to do to the other side. So I'll put that 2 right there, and I'll end up getting 4 squared, which is going to be 16. So subtract 3, and x is equal to 13. Okay, so again, 13 plus 3 is 16. 4 to the second power is 16. We're good to go. So here we go. Without identifying the methods, here's what I'm going to try to do. I'm going to try to get 5 to some power all by itself. I'm going to take away the 3. So yeah, I want to get it so it's the exponential by itself of what, 22. I could try for the same base here, but what's going to be a little tricky because 22 isn't 5 to some power. Nope. So I'm going to have to take the log of both sides. Now, really I can take any log, but I'm going to take log base 5 because these two are inverses, and I'm left with x plus 2, and log base 5 of 22. Going to use the change of base formula. So again, it's common log, the one that's on your calculator, of the number over the common log of the base. And because of the plus 2, I'll subtract 2 from both sides. And there you go. X is equal to log base 10 of 22 over log base 10 of 5 minus 2. That would be your calculator ready form. So if I said, hey, go ahead and do this without your calculator, that's what it's going to look like. If you actually want to figure it out, go right ahead and you can figure out that decimal. And what it ends up being is roughly negative 0.079. Now, I'm not worried about that negative exponent because we've got exponential and not log, and exponential's domain is all real numbers. Okay, alrighty then. Well, I'll say this, you can't do this one because we haven't done the plus, so I'll do that part for you. This right here is going to turn into log base 2 of x squared minus 7x. Okay, so I'll do that for you. Don't worry about that property. Again, you get to pre-calc, you'll do those kind of properties. But they're not both log base 2. So what I'll do is I'll raise these as exponents, and I'll pick base 2. Why? Because this is log base 2. So log base 2 of x squared minus 7x equals, and then log, not log rather, 2 to the third power. So over here, they're going to cancel out, and we're left with x squared minus 7x. And over here, we're going to have 8. We got yourself a quadratic, so you got to get it equal to 0 before we solve. And I think I can solve by factoring because there's factors of negative 8 that will add up to be negative 7. And let's see here, we got x minus 8, x plus 1. So solve both these, and you get x equal to 8, x is equal to negative 1. If I put in negative 1 minus 7, that is the log of negative 8. That one right there is extraneous. So 8 is my answer. Okay, so here we go. Just for the sake of time, I'll set this up for you. But you want to deposit $2,000, and you want it to grow to $2,500. It's compounding interest. It compounds quarterly. So we're going to go 1 plus your interest rate of 0.02 raised to the divided by 4 raised to the 4t power. Okay. You're trying to get this by itself. This 4t. So if I simplify inside the square root, 0.02 divided by 4 plus 1, that's going to be 1.005. 4 to the t power. Resist multiplying this 1.00 by 2000. What we'll do is we'll divide both sides by 2000. And those will cancel out. So we got 25 divided by 20. We got that equals to 1.25. Okay. Log base 1.005. Log base 1.005. Why 1.005? That's my base. Okay. Change the base. We'll make that common log of the number 1.25 divided by the common log of the base 1.005 is equal to 4t. So let's go log 1.25 divided by log 1.005. Okay, that gives me 44.7. I'm going to divide both sides by 4, and that's going to give me t is equal to 11.18 or 11.2 years. So it's going to take them about a little over 11 years to get that 2,000 and go up to 2,500.